Welcome. How's everyone doing tonight?
Hey,
My name's
hey.
John Kuchmek, and I have with me Mark. No. Whoa, 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 whoa. You're not Mark Payne. I thought
Nope.
Mark was supposed to be doing this. So instead of Mark unfortunately couldn't make it tonight. He had something come up, but he did get another NiFi engineer, another NiFi PMC to fill in his space. So as advertised, you still get a PMC, you still get an engineer who actually builds the product. But we have with us Mr. David Henderman. So
Hi.
Dave, how you doing tonight, man?
Doing well. Good to be here. Thanks.
Yeah. So Dave is from the great state of Texas. So we have
Recently,
a little
yep.
bit of a central time for the East Coast guys like myself out of Philly, but I know we have people all over the world that are here tonight. So what I want you to do, regardless of the platform you're in, if you have the capability to comment, tell us where you're from, whether it be the city and, essentially the country as well, because I know we're pretty global here. I know there's a lot of people that registered for this meetup. So it'd be really interesting to find out where all these people are coming from. While we're doing that and we get people kind of getting going, David and I were actually hanging out a couple weeks ago. We were in Current, which is, they had it in Texas. It used to be called Kafka Summit. They changed the name. So that was a little strange for me, but we got to share some beers and barbecue. And so I would say, yeah, what was your favorite barbecue that we had? I'd say out there.
Probably the the pulled pork. I think the pulled pork was the best I
Pulled pork.
had. That
Yeah.
was took a little drive outside of Austin to get there, but it was well worth it. Well worth it.
I think that potato salad was ridiculous from that place.
Yeah, I had never tasted anything like it.
I can for the life of me, I can't remember what it's called now.
The salt lick.
Yeah, the salt lick. The salt lick. I'm telling you,
Genuine Texas barbecue.
Best potato salad I've ever had. But we also, we were waiting. So Dave and crew got lost a little bit, and I was sitting there, and unfortunately, I didn't realize that there was a bar behind, and so we also got to share some beers, got to share some local Texas beers. So, if you just are joining us and you didn't tell us where you're from, why don't you right now in the chat, why don't you tell us what your favorite thing to drink is? It doesn't have to be alcohol related, although I'm a big beer, and bourbon guy myself, but, give us an idea of the things that you like. And, let's make this a little bit interactive. So David, you've been, building NiFi for a few years now, right? I know you joined the team recently, but, at Cloudera, but you've been building for a little bit and you've been an engineer for a little bit. So maybe a little bit of your background from that perspective and then.
Sure.
Yeah.
Yeah. I've been developing NiFi custom components in past jobs. Really appreciated the flexibility of it, and then joining Cloudera and working on the open source side, contributing directly to NiFi the last 2 years or so. Initially as a contributor, and then as a committer, and then also as a project management committee member now for over a year. So it's been a great run and doing a lot of great stuff.
Yeah. And if you guys haven't followed, so David's got a whole website, it's exceptionfactory.com, right? So he puts out like blog posts of the stuff that he's building. I mean, he made NiFi secure by default, right? I mean, that was something that wasn't there.
Effort.
Yeah.
114. Yeah. Yep, that was big.
And I noticed, like, I've been watching, following you. You're clearing out some technical debt too of the the old school builds.
Yep. No, there's always more to do. There's great community participation trying to keep up with various dependencies. Sometimes those are easy. Sometimes those require significant refactoring. But yeah, trying to keep things fresh, introduce new capabilities without breaking things. Always a great challenge.
Awesome. So for those that don't know me, this is your first soiree into a meetup or a webinar. We've done these before. My name is John Kuchmek. I'm actually a principal solutions engineer. I sit right outside of Philadelphia in South Jersey. And for those that have just joined us, so we've already been talking back and forth, but I have David Henderman, who is actually a principal engineer at Cloudera and a NiFi PMC. So before I pass everything over to David, I wanted to let people know that we want this to be interactive. If you are able to go ahead and ask questions, so we have many different forums, we're collecting all the questions and we're going to stop for a break somewhere in between and then answer those questions. One thing that's really, really cool is that if you ask a question, you automatically get entered to win a prize. So We have some really cool swag that we're going to give out. Maybe we can show some of that swag right now, but we're gonna basically have the capability for you to win, a couple different prizes. So if you actually are able to ask questions as we go, then we'll be able to go ahead and say, all right, check out, at the end of the day, we'll have a wheel to spin. I'll spin the wheel with all the names entered, and then we'll select, names from there, and then we'll be able to actually mail out those prizes. And some of the swag is really cool. So I definitely want to say to check it out. So that's enough of me talking. I think we've been talking for about 5 minutes. I think that's all I should talk, really. I'd rather pass this over to the real man, the guy who's going to kind of walk through really cool stuff with NiFi that he's actually built, including a demonstration. So David, take it away, man.
Thanks. Appreciate it, John. It's great to be here, and jumping right into data enrichment in line with Apache NiFi. So before we get to demo, just a brief run through of what we want to talk about here. So set some background, talk about complex event processing generally. Where does NiFi fit in the overall landscape of things? Dive into some event enrichment use cases, why you would want to do enrichment, different types and ways you'd want to pull information together. And then focusing in on NiFi particularly, we'll talk about enrichment strategies in NiFi itself, various processors, how you can put those things together, what kinds of guidelines to follow. Then before we get to the demo, I'll give an overview of the scenario using some newer processors, the fork and join enrichment processors, which allow some really complex and powerful ways to aggregate data from a variety of sources. Then we'll jump into the demo, show NiFi and the flow we built to demonstrate these capabilities, and then we'll wrap it up, come back and hit the highlights from the flow. Just so there's a lot there, so stick with me. And again, as John said, feel free to enter the questions, and we'll about halfway through, we'll jump in and see what we have so far. So first, some background on event processing systems generally. As John said, we were both at the current 2022 conference just a couple weeks ago. And one thing that struck me about that is the number of products and services out there that do some kind of event processing. As John said, it used to be called the Kafka Summit, but in the effort to broaden the horizon, I really appreciated the efforts to do that. I presented on NiFi. There are a number of other great vendors, products, talks there. But it really highlighted that a number of products are making event processing a first-class citizen in their internal pipelines. So think of products like MongoDB or Redis, Hazelcast, services, products you might consider supporting various particular use cases like caching or object storage. But now that they're bringing event pipeline, event aggregation, and handling to the product itself, really highlights the importance of streaming processing, event processing within a product. Again, the landscape is also really broad in terms of external source integration. So we'll set that background a little bit more and then dive into where NiFi fits in all that. So event handling generally usually involves some kind of ingest, and that ingest usually involves some kind of formatting. You think data transformation from, say, a legacy format to something more standard like JSON, or maybe Avro for a binary, well-formatted, schema-driven event. Also, complex event processing is very popular and very useful capability where you want to do things like aggregation and summary across windowed bits of time. So again, there's many tools out there to do that. Just highlighting a few of the open source products that are available. There's Apache Flink, which, as their tagline reads, stateful computations over data streams. So it allows you to do complex SQL-like operations regardless of the source. So platform agnostic, you bring your source in, and then you can do those computations. Also, Apache Spark's been around for a number of years, very powerful. Especially in the data science world, supports multiple languages, Python, R, and of course Scala and Java, to do large-scale data analytics, historical kinds of aggregation and summaries. So NiFi fits in that structure, providing directed graph routing and transformation. So NiFi is not a stateful windowed event processing system in itself, but it allows you to format, join, filter, and basically prepare data, and even do some basic analysis and summary before you perhaps pass it on to a relational database or an event streaming platform such as Kafka or something else. So Apache NiFi, if you're not familiar, we'll just hit the highlights, and hopefully more of that will come out during the demo. As mentioned, directed routing and transformation. So think you have a source that can be anything from an SFTP server hosting CSV files. It could be a relational database. It could be blob storage from a cloud provider. Basically get your data in from some source and then do some amount of filtering or transform. I already mentioned the use case. Maybe you have a CSV, you want to turn it into JSON, or you want to filter and route and store it in the long-term storage in a compressed format, HDFS, lots of options there. And Apache NiFi builds that using an extensible component design. So the open source version has hundreds of processors and controller services that allow you to build very complex data flows. And also that basic API supports building your own custom processors. So it's not limited to what the open source framework provides. And then bringing that all together, it has a web interface that allows you to both design your flow and monitor it in the course of building it, which is really helpful for iterative development, evaluating, did this processor do what I wanted it to do? Do I need to add error handling? How do I handle error conditions, retries? And then, what kind of flow rate am I getting from this source system? So lots of capabilities built in. Again, if you've never seen NiFi before, here's a quick screenshot of the canvas, which we'll see more in the demo. At a high level, you've got a very summary of all the components running, things like queued flow files, the amount of data queued, the number of processors running, stopped, or in some other state. You can see at a high level the components on the canvas are a processor, the core unit of work, and that can be connected to one or more processors or combined together in a process group. In this example, that process group has two processors running, one stopped, and you can get a sense of the amount of data queued while that's stopped. So there's a lot more to it, but again, if you've never seen it, hopefully this gives a general idea before we jump in down the road. I mentioned flow files. That's the core unit of processing in the framework itself. Flow files are size and structure agnostic. So they're essentially the combination of metadata. So think just key value pairs and content references. So you can have anything from a small file of a few bytes of text to a large video, multi-gigabytes. It really doesn't matter from the framework's perspective in terms of what you want to do, but the type of data you're processing will drive what kind of processors you want to select. And so one of the things we're going to focus on for the demonstration and for event enrichment is record-oriented processing. So flow files could contain one event. Think, again, JSON's an easy example, one JSON object, or they could contain thousands of events. Think a batch of logs from system output, maybe 10,000 lines in one file. That would allow you to do bulk transform and achieve really high event throughput using record-oriented processors. That's one of the key things of flow design, and that's one of the optimization things we'll highlight in the course of the demo example. So zeroing in on event enrichment in particular, there's a couple different ways you can do this in NiFi at a high level. There's more, you could take different directions in it, but we'll try to cover the basics here. First, just generally, what would be a reason you'd want to do an event enrichment? Well, one might be to enrich dynamic data from static sources. Well, again, we'll touch on these in more detail. You also might want to defer duplication until needed. Think you have data from multiple locations. You only want to pull it together at the point of relevance and not carry it along where it's not relevant. And also you may want to evaluate data across disparate sources. Think you may have an internal repository, you may have cloud hosted resources, you want to pull those together. There may be permission issues to consider that might make it difficult to co-locate that data in the same repository, and keeping those separate and having clear access boundaries has some positives, but also makes it more complicated. But emit enrichment allows you to bridge those gaps in a well-defined way. So dynamic data enrichment, very popular ways of doing things, can be access log, geolocation enrichment. Think geolocation of IP addresses on a web log. So you want to see what country is someone coming from to get a sense of where my primary visitors are coming from. Or order processing. Think you've submitted an order, you need to get the customer address information in order to do the shipping and handling. Also threat detection. Perhaps you might have a system that hashes all content payloads, and then you want to look up those hashes against a known list of malware. In many, many use cases, this is just a snippet of the possibilities. As I mentioned, deferring duplication is an important reason you want to do data enrichment at the time of relevance. So one reason you might want to simplify the communication contract. If you can pass just an ID reference, that keeps the data contract between services much simpler than having to pass an entire object definition that may need to change independently over time. And again, as mentioned, you want to defer that lookup so you have the latest information possible. And again, referencing disparate sources. So you might have a relational database that has a reference identifier to a document store, or you might have internal documents with status details that you want to pull from a remote system, or you might have a remote, might want to search a remote repository using defined keywords, things like, you might have a document, extract the text, and then run searches based on certain extracted keywords. So lots of cases where data might not be co-located, but you want to pull that together to provide something new and useful. So how would you want to do that in Apache NiFi? There's a number of ways you can do this, and we'll touch on and provide examples of several of them shortly here. So at a high level, there's several processors we'll be looking at. First one, just touching on, for example, is the lookup attribute processor. We'll also be focusing in on record-oriented processing. So the lookup record processor lets you do a search based on an individual field, and then the complex joining using an entire record set using the fork enrichment and join enrichment processors. Just a little bit more detail on the flow file attribute lookup approach. The lookup attribute processor requires a lookup service. So there's a number of these that are built into Apache NiFi, everything from structured file options, think CSV, XML, JSON, to dynamic services, things like Elasticsearch, MongoDB, relational databases. Basically, there has to be a lookup service implementation to provide that attribute information. In order to use this processor, as the name implies, you need to read flow file attributes, so that metadata about the flow file. This is helpful, again, if you only care about the metadata, and you only want to enrich the metadata, then this processor does that job well. But if you're concerned about the content, it would require a lot of additional preparation, extraction from the content to attributes, which can be expensive and not optimal for some use cases. So it has its purpose, but depending on what you want to do, it may not be the best fit. The record field lookup approach uses the lookup record processor, also uses those same lookup services I mentioned, but it allows you to stay within the context of the data itself. So if you have a file that has 100 records, and you want to take one field and then do a lookup based on that one field and return additional data, the lookup record processor is a good example of that. When you're doing that, as you might think or expect, given the number of records in a flow file, you want to make sure that you've optimized that lookup service. Think, for example, if you're doing a relational database lookup, if you have not indexed the key that you want to look up, it's going to be slow. You might be able to get around that using some localized caching, but again, there's pitfalls there if you're trying to do just a field-based approach that may have a lot of queries required. So it works well for record-oriented data and simple field lookup, which we'll touch on, but has some limitations as well. So the main feature we want to look at in the demo shortly is some newer processors, the fork enrichment and join enrichment processors. These were released as part of Apache NiFi 1.16, which has been out for a handful of months now. And they support any kind of enrichment you can build using the flow itself. So as we'll see in the demo, the fork enrichment will prepare the file for processing and then allow you to build n number of components, stitch them together, do transformation, do lookups, and put that back together using the join enrichment processor. So things that might have taken multiple queries, you can now aggregate and do one query by sending all that information as part of the query. One of or actually two key points to keep in mind when using the join enrichment processor, there's a timeout and a join strategy. So those are key when building your complex record set enrichment. The timeout basically instructs a join enrichment how long to wait for that complex enrichment processing to run. So for example, if it's a long running process, you want to make sure you set that timeout with enough time for it to complete. There is a timeout relationship which will send the flow file down if that enrichment processing takes too long. Then the join strategy we'll touch on. There's multiple ways to do that depending on what you want to do. So, been talking for a little while. I don't know if there are any questions yet. John, any questions to cover? Things maybe even you want to ask at this point before we jump into the scenario?
Yeah, I'm actually I'm pretty much interested in the fork and the join. I know 1.16 has been out for a little bit, not too long, right? I think it's a little under a year at this point.
Yeah, I think summertime.
Yeah, summertime. So NiFi is getting a little closer then to be able to do, you know, some transform operations that we used to not do in, you know, in NiFi at all. So when you think of NiFi, we used to say ETL with a lowercase t. It looks like that T is getting a little bigger. Is that the case? Is that the direction of NiFi?
Yeah, I think that's a fair summary. One of the processors I'll be highlighting is query record, which lets you do a lot in one processor. You can change the data format using a reader and writer. You can filter the data using complex SQL. You can project or select which fields you want out of that. So that's just one processor. There's more, but yeah, definitely more has been added in recent versions to support different types of transformation.
That's pretty awesome. Well, I want to remind everyone right now too, is that, you know, we have a couple different platforms where you can ask questions on. I know one person asked if there's a recording link, and it looks like we replied yes. But if you have the capability, if you want questions, please ask questions. Don't hesitate. We're going to get to them. David or I'll answer them depending on what it is. And it also enters you a chance to win some swag. So of course we'll be sending it out. Now, the other thing is that as we walk into this use case, I mean, I'm a guy in the field that sees a lot of people use Apache NiFi. Matter of fact, it's pretty much the reason why I decided to come work for Cloudera, is to get closer to this product, because I used to use it as a customer myself. And so, you know, do you see a lot of the batch? It looks like the record-oriented processors, you know, they came about a couple of years ago. But that's because, you know, it went from being a data flow tool, and then a lot of people started using it for batch processing as well. So, I mean, how many customers would you say are using it for flows only, or a mixture of the two, and can both exist within the same canvas?
That's a great question. I don't have I think it's hard to say which kind of narrow use cases, but I think in most of the customers that I've run across, they're doing some kind of event-based processing. Oftentimes, you know, customers that have been using NiFi for a while have, you know, found workarounds or found ways of doing things that worked for the time, but started to stress the framework and led to the development of the record-oriented processors. So Mark Payne, who, as you mentioned, can't be here, has some great anti-pattern videos on YouTube. Definitely recommend checking them out. But that's something if you're new to NiFi, it's a great time to jump in because all these pieces are there now. If you've been using it for a long time, it's a great opportunity to jump in and review, see what's changed, and perhaps refactor, rebuild, redesign, or optimize processing where you can really get a lot more event throughput by using some of these newer processors.
So we do have a question. They're asking, are there commercial products using NiFi? So I guess I guess I'm assuming this could go one of two ways. Are there commercial products that are being built that are using NiFi in the back end and then they produce something, or are there commercial products that use NiFi as the complete engine, not just a piece? So I know for the complete engine part, we definitely have one. But anything that you could kind of discuss or talk about?
Yeah, I'm trying to think of some good examples. I mean, I've certainly seen one example comes to mind from some community discussions. Folks have set up a web service or kind of request processing system. I'm not sure of the details of it, but basically NiFi has handle HTTP requests and handle HTTP response processors that allow you to essentially build a web service to do any number of things based on HTTP request. So I think that's a pattern I've seen in a few places. I think in a lot of cases, NiFi works well as a supporting tool, basically providing the glue to put things together. Now there's quite a few companies using it. I'm not sure if you could say it's just built on NiFi particularly, but certainly as a key part of the architecture. It's kind of a general answer, but.
No, and of course, Cloudera Dataflow and all of our Dataflow products, which includes our universal data distribution, is of course exclusively built on Apache NiFi. Now, with that being said, so that came from Harold Kraus, and he has another question. Is NiFi a full streaming service like Kafka, no start endpoints, or is it a micro-batch service like Spark Streaming? And then he's got one additional question past that.
All right.
I'll group them together even though they're different. And
okay.
Are there managed services for NiFi built in any of the big three cloud platforms like AWS, MSK, Azure, GCP?
Great questions. Great questions. So jumping back a little bit to the introduction, NiFi is not a streaming platform analogous to Kafka in terms of it's not a you don't have topics per se where you write a distributed log or something like that. NiFi integrates with Kafka and many other cloud providers, Azure Event Hub, AWS Kinesis. So in terms of data preparation or reading from and responding to events from those streaming services, NiFi fits well in that category, but it's not a replacement for or an alternative to Kafka in that way. Also Spark, again, it's not a replacement. It's not a long-term storage and analytics engine in that way. So it's built for getting your data where you need it to go so that you can do those complex data science type of operations.
Yeah,
and then on the other question, go ahead.
Well, I just want to add a little bit to that too, right? So NiFi has the capability to have zero latency and just let everything kind of flow through. And you'll see there's certain processors where there's a slider bar where you can actually increase the latency to make it more of a micro batch perspective, which behaves more similar to the way that Spark, structured streaming works. And you actually can, slide it to I don't think it's 25 milliseconds, 50 milliseconds. So depending on the way that you want. And you do this a lot, to help with a lot of records flowing in at the same time, but you want to batch them together and process them at once. And that's really because I think NiFi, you're writing to disk and then bringing it back up. But, you also can just let the stream open up, right? In the sense that, if you're just reading a continuous stream of data and have zero latency. So, something is a differentiator. And then, yeah, if you want to talk about the managed service built on the big three cloud stuff, sorry. Didn't mean to interrupt you, David.
No, that's a good clarification. And yeah, I think we'll touch a little bit on that in the demo. We'll essentially be dealing with micro batches of events related to GitHub pull requests. So that'll show an example where you could run an operation on that micro batch. You might want to merge it together, but once it's processed through NiFi, then if you wanted a longer term or a windowed evaluation, that's where some of these other platforms come into play. As far as services, I'll be demoing the Cloudera data flow service to launch the NiFi flow and jump in. So that actually runs on either AWS or Azure. We're looking at GCP in the works, no timeline that I'm personally aware of, but basically it deploys NiFi on Kubernetes and manages that deployment. So automates a lot of it, and won't be the primary focus of the demo, but we're highlighting a few of those capabilities.
Yeah. So we have from Steph Nestor, how does NiFi queue work compared to Kafka? So it's another NiFi versus Kafka question. Does it ever hit a load point it needs to outsource that queuing to Redis or Kafka? I'm thinking he's talking about maybe back pressure of a flow.
Yeah,
that's what it kind of sounds like, load and back pressure, but I don't know if you want to take that.
I'll try it. Yeah, feel free to jump in or add on. Not familiar with all the internals of Kafka to offer the best comparison, but yeah, so NiFi has configurable queues between processors. So as you mentioned, John, you can have back pressure there based on the number of flow files or the data size. You can have configurable prioritization. As far as what to do with extra, or what happens after the data is buffered, there is a swapping to disk that capability that's there. So there are ways of dealing with it. It's probably not the best answer, but I don't know, anything to add to that, John?
Yeah, I mean, so the first thing that comes to mind for me with Kafka is typically you have a certain amount of partitions and then they're across brokers within the stack, right? And you could have an unbalanced, essentially, workload where some of the brokers actually get a lot more messages than the rest of the brokers based upon how many partitions are set up or how many topics you're writing. And that's why Kafka does have tools to do repartitioning, like cruise control, right? Which is what we do to rebalance Kafka. So NiFi does run on the capability to have a primary, and then you also have the rest of the cluster. So in a clustered mode, you could, depending on whether it needs it or not. So when you look at consuming Kafka records from NiFi, it already distributes the load pretty evenly across the stack. But when you're doing, say, a list file, fetch file process, when it goes to list that's running on a primary node, you don't want it to run across, because then it's going to do data duplication. You're going to essentially have each node is going into the system and maintaining the state of that data in that list file. And so putting a round robin or some sort of load balance, there's actually a capability in NiFi to build a load balance connection, and that'll distribute the load evenly across the cluster. So, they kind of work in a similar fashion, except, when you have when you're running everything from a primary start and you don't go to rebalance it, then you end up with something skewed that's comparable to Kafka. The big difference is you can actually design your flows up front so that doesn't happen, whereas Kafka, it's kind of hard to design it that way. And then once you actually see it, you have to, essentially use something like cruise control to do the rebalancing across all of the brokers. But so another question, this one's from Andy Anderson. Okay. Is NiFi a plugin for Apache or a separate service?
Yeah, separate service, I think, is the best way to think about it. NiFi builds on a number of other Apache libraries, and one of which I'll be mentioning is worth highlighting now is Apache Calyx, which is not a product per se, but it's integrated in a number of tools, including NiFi, to support SQL-based operations against configurable data, in this case, records. So Apache NiFi is a full stack application. It is also worth mentioning that there are other form factors for NiFi. There's MiNiFi, which is designed for edge deployment. So it does not have the full web interface and design and monitoring that you see in traditional NiFi, but it allows you to run all of the standard processors in a configurable flow. There's also stateless NiFi, which is something that's been a focus in a lot of community and development interest lately. That allows you to package up a flow, deploy it with just the processors you need, and then run it in an environment without any kind of long-term processing. So think serverless functions through cloud providers, or Kafka Connect. There's NiFi connectors for source and sync that build on and leverage the stateless engine of NiFi. So although the traditional NiFi, which is still the primary focus, remains a full stack product and service, there's also these other deployment form factors that are available.
Yeah, I think the stateless stuff is pretty cool. I mean, I've seen, when you want to not have to worry about writing things to disk, you just need the speed and keep it all in memory. You can run it stateless. And the NiFi function, like the functions, is really cool too. Building a Lambda function, having those ephemeral workloads just run.
It's pretty powerful.
Yeah, the Kafka Connect. So I know this isn't the point of this, but I think this is a pretty awesome thing because there are K connectors out there, but there's only a handful. Last I checked, I think NiFi's got like 328 processors, something like that.
More of a count than I've got. Sounds about right.
Yeah. So can you dig in real quick about like what you could do with NiFi to build a Kafka Connect? I know it's not the point, but since there's a lot of Kafka questions here, I think it would be cool to highlight that.
Yeah, it's worth mentioning. It is so the Kafka Connect, the NiFi Kafka connector is downloadable through Maven Central, recently linked directly from the Apache NiFi downloads page. But essentially, that contains just enough of the NiFi core, the stateless engine, and the Kafka client libraries to build and run the flow. So what we'll be showing shortly is something that you could almost take and run in Kafka Connect with minus a few parts of it. But essentially, once you've built your flow definition, your connection of processors, process groups, all rolled up into one process group with any other supporting controller services, you can download that, and then you can run that using the NiFi Kafka connector. So using traditional NiFi as your design platform, you can then export that, parameterize it. So things like database connection credentials, those pieces can be supplied at the Kafka Connect runtime. And so you can build, again, a complex transformation capability using NiFi's out-of-the-box processors, and then just run that using a Kafka sync or source connector.
So I can build a low-code / no-code Kafka connector.
Exactly. Yep.
That's pretty awesome, actually. All right, so we're going to let you continue on. It looks like we've paused on some of the questions for now, but I just want to remind everyone, if you have questions, fire away. You don't have to wait. Like I said, we'll get to all the questions at the end of the demo. So we're going to do demo review, and we'll come back to David again with questions. So please don't hesitate to ask. And even if you're not going to be around to hear your question, everything will be recorded, so you'll be able to listen to it later on. And like I said, you get entered to win a prize. So David, take it away.
Thanks. Thanks for the questions so far. Keep them coming, and we'll hit them at the end. All right, so fork and join enrichment. So before I get to the demo, I just want to do a little bit more setup and what we're trying to do here. So the purpose of this demo is processing pull requests. So for those of you who may not know, we're celebrating Hacktoberfest this month. There's Oktoberfest, celebrated with German heritage beer, lots of things, but Hacktoberfest is a celebration of open source contributions, and Apache NiFi participates in that. So had a lot of great community contributions throughout the month and all year round. So it's a common problem and a common challenge as a member of the PMC to review contributions, whether that's those from project members or through first-time contributors. Those are great and helpful. But as part of day-to-day work, there's always a balancing of what takes priority. So what we wanted to do for the demo is put together a simple example of merging GitHub pull requests with Jira issues. So Apache, as the Apache Software Foundation, hosts an instance of Jira, and Apache NiFi uses Jira for issue tracking. GitHub itself has an issue tracker, but NiFi doesn't use it. Most projects currently use Jira. So there's a lot of valuable information in the Jira issue, things like when it was created, the number of watchers, the number of votes. All these things are helpful in evaluating the priority of that pull request, but that information is not there in the pull request itself. So for the scenario, what I'd like to do, or what I put together, is we want to flag pull requests that don't have a Jira issue key. So in order for that linking to happen, the title needs to have that issue key. But if it doesn't, that's a kind of first level, hey, we need to track this down, make sure it's tracked to a Jira issue so we know which release it goes in, when it's actually completed, and all those things. Second, we want to be able to score pull requests based on issue status. So things like the issue priority that I mentioned, how long the issue's been around, whether it's a bug or an improvement, all these kinds of things that Jira has, we want to be able to evaluate pull requests based on that information. And then finally, highlighting pull requests based on contributor membership. So again, there's always great value in first-time contributors, and we try to focus and encourage contributions, like I said, especially this month, Hacktoberfest. But those who are members of the project are usually aware of kind of the larger scope of things. They know the process well. So some of the initial triaging is not usually necessary because they know the ropes. So at a very high level, before we dig into the flow itself, we want to be able to take GitHub pull requests and then pass them through fork enrichment processor. And then the original data, the pull request, will go to the join enrichment processor. And as part of the enrichment process, we'll make a search, we'll make a REST call to Jira's API and put that all together so we have that information in one record. Also for the project membership, as an example of the lookup record processor I mentioned earlier, we'll be using just a simple CSV file. There's a simple CSV lookup that has the GitHub username and the project membership status, whether committer or PMC. So, you could plug in other sources, but CSV provides a nice, straightforward way to do this. Just a quick summary of the services we'll be interfacing with. Both GitHub and Jira, thankfully, have great JSON-based REST APIs. So you can pull pages of JSON pull requests from GitHub. You can also search Jira using their Jira query language. And then, as I mentioned, we'll be using just a CSV that I've created for mapping GitHub usernames to project membership. Couple key notes on the GitHub pull request API. It's fairly straightforward. There's the URL. You have Apache as the organization. You have NiFi as the repository, and then pulls after that. The default response limits the number of response objects to 30. So at any given time, there's usually more than 30 pull requests out there. There's been hovering around 50 and 60 lately. So we'll need to page. GitHub, to support paging, they return a link header in the HTTP response. They formatted it a little interestingly, so we'll need to do a little bit of string parsing to get the URL out of there, taking it out of the angle brackets, and also identifying it with that rel equals next. They also have previous or end or last in that same link header. And finally, very importantly, for GitHub, they have rate limiting on requests, so we don't want to spam their API and then block the whole flow from running. Just a quick example: the pull request object has a large number of fields. We only care about a few of them. The title is the key one that will have the Jira issue key shown here, NiFi 10,000, followed by a short summary. We also have the created date in a nice ISO 8601 timestamp format. And then we have the GitHub user in a nested object. So there's a user object that has a number of user attributes, and the login is one of the key pieces we'll be pulling out. A quick overview of the Jira issue API before we get to the demo itself. Again, their URL is pretty simple. Just ends with /search. Their API returns up to 50 objects, and unlike the pull request, the GitHub pull request API, it returns those objects in a nested issues array. So this is important when we come to parsing the JSON into records, and this is something we had to add recently as a configurable feature for the JSON reader. So we'll come back to that. As I mentioned, Jira supports a Jira query language, similar-ish to SQL, JQL they call it. So you can build up a Boolean query, a where clause essentially, where we can say issue key equals this or this or this. So it allows us to do an aggregate search for all the pull requests in one HTTP request. And again, just like GitHub, there's rate limiting, so we don't want to abuse the service. Some key fields from the Jira issue. You have the key, which we'll be referencing. Jira also organizes its fields. There's custom fields and standard fields. They have a created field with a similar timestamp. There's a priority object, which has a name, also has some other information, as a creator object, an assignee object, again with name. So a lot of nesting, and that'll be important when we're parsing and wanting to simplify the record structure. The CSV, as I mentioned, pretty simple, just the username and contributor status. So once we've got that enriched flow file, enriched records in the flow file, there's any number of potential destinations. For this demo, I'll be sending it to a MySQL relational database, but as we mentioned, NiFi supports many, many processors, so it could just as easily be sent to Kafka, be sent to S3, any number of destinations, depending on what you want to do for follow-on event processing. So with that, let's jump into the demo. All right, so as I mentioned, I'll be running this from Cloudera's managed data flow platform. So John stood up an environment for me, and so that's allocated the Kubernetes cluster. There's a data catalog where I previously created my flow definition in NiFi in a separate instance and then uploaded it to the catalog. So I've actually made two versions of this. You can click on it and get a quick sense of what changed. So I added a second version where I added a new parameter, but just allowed me to comment on that. And then from here, we can go right to deploy, picking that environment. I've already deployed it, so we'll jump straight to that. In the dashboard, we've got my running NiFi instance where I've got a quick summary of the flow itself, the name I gave it, GitHub pull request, a very high level summary of the data in and out. So I've got it running on a regular basis. And from here, we can jump right to the flow itself. Manage the deployment. So you can see here a quick highlight of the deployment status. So everything is running well. The cluster's healthy. I've only got one node. We don't want to use a cloud resources for this demo. We could have enabled auto scaling based on CPU usage, but don't need that in this case. Got the NiFi runtime version. It's just a nice snapshot of what's going on without going into NiFi itself. And then, as I mentioned, I parameterized the flow. So this is key, leveraging NiFi's parameter context capabilities and then plugging those into the flow definition. So this allows me to abstract my configuration from the flow definition itself. So you can see here, I've got my database connection URL to Amazon RDS, my JDBC driver jar, the database credentials, and then I've also parameterized the URLs for GitHub and for Jira. So theoretically, this flow definition could be built and run against a standalone instance of GitHub and Jira. And then finally, the contributor CSV as well. So all that's there, it's deployed and running. So right from here, I can jump in and view NiFi. So here's the high level process group. So we've got 35 processors, and I won't go through all of them. So I don't want to bore everyone, but I'll try to hit the highlights and then circle back to summarize. So at a very high level, like I said, we want to get the pull requests from GitHub, and then we want to process and enrich them. So leveraging process groups allows me to keep things manageable without having a sprawling flow definition. So just to kick things off, I've got a generate flow file that's run every couple minutes. Let's see, I've got that running every 2 minutes. So pull requests don't come in all that often. So this is more than enough for this purpose. Just a key thing to note here, the standard invoke HTTP processor retrieves that JSON, but then to get that next URL, we've got a little bit of a loop here. So we pull out that link header and then parse it using a simple expression language. So here's that link header, and then using a little bit of regular expression fun, we're able to gather everything in between those angle brackets and followed by that next relationship, and then replace the entire value with the matched group. So that's a little bit in the weeds in terms of regular expression, but powerful. And now we've got our next link to decide if there is a next link, then we want to route on it. We want to update the URL and run it again. So for any given initial execution, there could be n number of actual HTTP request calls getting those pages of 30 pull requests. So in this case, we get about 2 or 3 HTTP requests, and that gets all 60 plus. So once we've got the pull request, let's take a quick look at the data itself. So using NiFi's data provenance capability, we can just right-click on a processor to see what it's done. So you can see here, it's updated that attribute and then sent it on. We can go from here and view the content to get a sense of what the JSON actually looks like coming back from GitHub. So let's pull that up. Here's the viewer, and since it's JSON, NiFi can format that nicely. So as you can see, there's a lot of data here. There's all the issue information, as I mentioned, lots of user information available, requested reviewers, labels, all the things about the source repository, the destination repository, and that's just one record. So all the way links, and then there's the next record, 300 plus lines later. So there's a lot of data for this purpose where you only care about a few of them, but it's obviously important to understand what we're dealing with to start with. So now that we've got our pull requests, we will need to enrich them. So in this process group, we basically have initial formatting and followed by the Jira issue retrieval, and then the actual processing that's sending to MySQL in this case. So the formatting, basically what I want to do here with query record is slim down the number of fields that I actually care about. So this is helpful in that it shrinks the size of the flow file, and it also makes it more manageable in terms of provenance tracking, those kinds of things. So you can see here I had 4 files in totaling over the last 5 minutes, totaling almost 2 megabytes, 4 files out, only 50K. So it's not absolutely essential to do this at this point, but it's helpful to kind of focus in on what we actually care about for this purpose. So as I mentioned, query record has a lot of capabilities. It has a configurable record reader and writer. In this case, I want to keep it as JSON, so tree reader and tree writer, record set writer. And then you can configure one or more SQL statements to select, filter, and project the fields you want. So you maximize this here. So the initial part of it's probably familiar, just selecting those field names. And that works well because these are top level fields. But since we're dealing with nested JSON, we need a way to deal with that nesting. So NiFi, building on Calcite, Apache Calyx that I mentioned earlier, has some user-defined functions that, in this case, record path or rpath string. So the first argument is the object, the top-level object that we want to evaluate. And then the second argument is a record path expression that allows us to select which element of that nested record. And you can do multiple layers of nesting here. You can deal with arrays. It gets a little complicated, but it has the power to get what you need and turn this all into a simplified list of fields that we care about for this purpose. And then the from flow file is the functional table at this point. But basically this select will run across every pull request record that's returned from that JSON tree reader. So as you can see, we got some basic identifying information, the title, which will attempt to parse into the Jira issue key, the creation, and then some user information. Here, making a quick use of update record, mostly for demonstration purposes. So previously we'd selected title as Jira issue key. So update record lets you specify a record path and then run operations on the value. So in this case, we've got the Jira issue key field, and we want to take the entire title and just select the Jira issue key. So again, using some regular expression magic. You can take the field value, so that's a well-defined available value in the expression language evaluation context when you're dealing with records. And we want to match on that. So we want NiFi dash some number of digit characters. And then we want to replace the entire thing with that matched group. So we end up with just the JIRA issue key if it's available. Now, it may fail, and we'll touch on that a little bit later. So once we've formatted and updated the issue key where we can, now the initial pull request records are in a state where we're ready to do the join. So let's jump over to Get JIRA Issues group. So here, as I mentioned several times, we have the fork enrichment processor and the join enrichment processor. Now, fork enrichment, there's no configuration, so there's actually not a lot to do in the properties section. It's all about the relationships and the attributes that the processor writes. So these two processes are meant to be used together. Fork enrichment writes those basic attributes, allowing join enrichment to pull the related flow files back together. And then the key is defining those relationships. So the original goes straight to join enrichment, where it will wait for the enrichment process to happen. So again, to kind of encapsulate that enrichment process, I've created another process group that's actually going to do the JIRA search before joining it back together. So diving in here, there's a little bit going on. I think that some things to highlight are the issue keys. So what we want to do is find all the records that have those JIRA issue keys. Then we want to take those issue keys and turn them into a JIRA query language expression that we can pass to the JIRA API. So there's a little bit in the weeds here. I'll show it and we can go back over it later on, but I'll reference it. So using some aggregation functions and string concatenation in the SQL query itself. So getting a little fancy, but basically we want to say issue key equals the actual issue key value. And we want to filter that where the JIRA issue key field in the record does not equal the title, meaning that that update record processor actually worked. So once we've got all those issues, we basically end up with a string of issue key equals or issue key equals, et cetera, et cetera, et cetera. And then we can pass that into the invoke HTTP where this is just an attribute. So JQL equals that long string. So this allows us, instead of having to do multiple REST calls for each JIRA issue, we can do one REST call for 30 issues at a time that fits within JIRA's limitation of 50 and allows us to return a set of records based on those JIRA issues. So again, query record coming in very handy. The key here, in addition, similar to the pull request, we've got a lot more nested data. So we've got rpath string, quite a few places are also rpath int. So there's votes and watch count. We want to call those out. So again, a lot there, but similar. You can see multiple layers of nesting here: creator, name, display name. But the key thing on the reading side, as I mentioned, JIRA issues JSON is returned with issues as the nested array that we actually care about for those records. So the issues tree reader is slightly different. There's a starting field strategy. This is a more recent configurable option. So instead of starting at the root node and saying, okay, we want to treat this array as an array, instead we can say nested field and give it that field name. So basically the reader will look through the JSON. Once it finds that starting field, then it will start parsing records. So this allows handling nested JSON without doing complex transforms, just to turn it into record-oriented data. So once we have that, again, we've selected it out. Let me show here a quick snapshot of the JIRA issue JSON, so we know what that looks like. Again, rather large. So you can see here, here's the object search result, tells me my total number of results, max results, and then here's that issues array key followed by all of the issue fields. So you can see there's a lot of custom fields, and then you've got the next issue followed by all of that. So again, lots of data. We don't care about all of it for this purpose, so we just want to select the pieces we need. All right, so now that we've run the query, we've got it together, now we need to join it. So there's a couple configuration options here. So we need readers for both the original data and for the enrichment data. So this would allow us to join, say the Jira data came back as XML, we could plug in an XML reader here and deal with it just as easily. Then we want to write it out. We could use the use a different record writer if we wanted to turn it into Avro at this point. Those are all configurable options. The key things here are the join strategy. There's a wrapper strategy, which basically just creates a high-level object with enrichment and original, and then puts the record pieces in those elements. It's a quick and functional, but it makes it a little bit more difficult to process later on. The insert enrichment fields require some additional configuration. So the option I went with here is using the SQL join approach, which has a nice expressive way to describe what we're doing. So we have the original data as that virtual table, and we want to left outer join that with the enrichment data on the Jira issue key. So again, the key thing here, left outer join. So if any of those Jira issues were not found, either in parsing or in the Jira search, we'll still get those pull requests. They just won't have the Jira issue information. So once that's joined together, join enrichment writes out the join data, and now we're ready to process it. So here, we're using query record once again, in this case, to do some filtering. So we've got two different select statements. One is where the issue is found. In this case, we want all the fields, and we're just adding an unknown placeholder here where the Jira issue ID is not null. So that's one of the fields we had selected and named in the query record after processing the Jira issues. So that'll go down the issue found relationship. Then we want to also track and handle separately issues that are missing the Jira issue. So it's just a simple select star from flow file where the Jira issue ID is null, and we'll write those records to a different relationship. So for the issue missing, again, sending off to a separate process group here. Just two examples to kind of demonstrate some of the capabilities here. So we have put database records, so it's going to write those records to a separate table. And also you might want to send an email, or you could use post or put Slack to send a notification, sort of some kind of basic alerting. For something within NiFi itself, the update counter processor is a helpful way to just track, okay, I've got some data here, let's keep track of it at a very high level. So actually using the pull request URL as the counter name, and then incrementing that by 1 for every record that comes through. And then, like I said, put database record sends that to that database table. Now, the more interesting side is once we have the data joined, what can we actually do with it? So before we do the actual scoring and some basic tabulation, the lookup record processor allows us to get that contributor project membership information and pull that together. So we've got that simple CSV lookup. Again, we're reading and writing JSON with the record reader and writer, and the key for that lookup is coming from the user login field. So we're using record path expressions again here to put that together. And finally, pulling it all together, the query record processor allows you to do basic analysis on, you could consider that group of records in a flow file, micro batch might be one way to think about it. So given the power of SQL and what you can do with Apache Calyx, here's some basic operations. So before looking at these, there's a simple case statement. So if the status is PMC, we want to give a contributor score of 4. If it's committer, then 2, otherwise 1. Pretty simple. We want to have a derived interest level field. So we want to combine watchers and votes from the Jira issue and score it that way. Also some basic date math. So taking time from now to when the Jira issue is created, so we know how many days ago that the issue was actually created. Again, you could do all sorts of things. This is just some examples. So with that, then we send it to MySQL. So that's the end of NiFi. Now, once the data is somewhere, you might want to have some way to visualize and understand what you've just done. So for this purpose, we actually made use of another Cloudera product, the Cloudera Data Visualization Service, to create some basic graphs and table summary of the data. So here is the pull request scored based on interest level. So you can see over time, so they've got some old pull requests out here. It's been around for a little while, so that could use some review. Also, this kind of pops out, interest level 23. That means there are a lot of watchers and votes for this on the JIRA issue. And then, of course, there's a lot more recent, which only have an interest level 1, which is the default if there's only one person who submitted it and watching it. Some other ways to evaluate that data, average issue in day or age in days, so you can get a sense of, okay, we're keeping up with the pull requests, or there's some long running ones that are going to throw off that. Get a simple pie chart. So we've got a lot of pull requests coming from non-project members, which is great. We can also see, where that dividing up ends up turning out. And here's a breakdown of those pull requests based on the JIRA issue, so issue priority. So since we've joined that data, we can actually do things with that joined information. And then last, to summarize, we've got a table of those pull requests using the title, those fields pulled out, and then a link to the pull request itself in GitHub. And finally, there's one pull request out here that wasn't linked, and because our regex was very particular, those lowercase i's didn't fit the match. So that'd be something where we'd actually want to go update the pull request, fix it, and then it will link up. Just as another example, you could also do the same kind of thing with Grafana. It's just pulling from MySQL, so we've got similar types of information. Also, the sky's the limit in terms of what kind of visualization you might want to do using that data once you've joined it together. So there's a lot there. Trying to jump back and summarize. I'll try to go through this quickly so we can get to questions. Just to highlight some of the key elements here, we talked about query record a lot. So it has that Apache Calyx integration for custom SQL queries, configurable reader and writer, and there's a whole separate part of the NiFi documentation on record path functions. So if you're digging into query record, definitely important to look into that. So update record, complex expression language. Again, there's separate documentation for NiFi on that feature. Again, query record, you can do complex filtering, that rpath string function we mentioned, and then those dynamic relationships. So had a lot of single relationships, but you can do multiples. The scoring, just a quick snapshot of that. Basic SQL allows us to do basic analysis on the data as it's flowing, but there's a lot more you do once it's reached some kind of destination or streaming event processing service. The configurable lookup record, lots you can do with that when you only want to enrich a particular value. And we highlighted the fork and join enrichment processors, definitely worth checking out, reading the documentation so you understand the capabilities. There's not a lot to configure with fork, but a lot more you can do with join. And again, we highlighted the SQL join strategy, fairly expressive in that it's actually the default value when you select the join strategy, so it helps you to get started. So again, just at a very high level, NiFi is great for joining disparate sources, doing complex enrichment in the ways we've highlighted. Again, it's not a long-term repository, so that's where you'd want to send to your service of choice for historical analysis, or send to some event streaming platform for windowed aggregation and those kinds of things. So thanks for paying attention, and let's jump into any questions that may have come up.
Yeah, so before we even get to the questions, I mean, I want to think about this from a use case perspective. And most of the customers that I deal with are using Jira, and they're using GitHub, Bitbucket, something, right, to track, everything that's happening. And I could think a Scrum Master would love to have a tool like this with a dashboard, right? If you think about, the sky's the limit. It's not just that, but there's a lot of groups that might have other groups watching it, like even within, say, like larger banking systems or healthcare, where there's a lot of segregation of duties, but they all kind of rely on maybe this thing being built out and being able to see that it goes. So having a dashboard, that not only could a Scrum Master use, but you could also look and see how the features are coming along, adding things like whether it's closed, whether it's a bug, bugs are fixed, right? Reporting, so the Jira things in relation to the pull requests, and then also, again, Scrum Master measuring the velocity of each person who's doing those things, from, who's doing the pull requests and putting them in. So I could also think of, like, just, you look at healthcare industry alone, being able to call, say, the Fire, right? So for those who don't know, Fire v4 API, and then doing enrichment. So having that fork and join enrichment of the data set. I mean, we get asked these things all the time with customers. So, this framework that you built out is far beyond just, the GitHub pull request. I think it can be used for a lot of different things, but, as people come in, like, if you guys have questions, I mean, this is the guy to talk to. Obviously, he's the guy who deals with the product every day. He's building the product. If you're ever on the Apache NiFi Slack channel, he's answering questions left and right. But yeah, so, I mean, we're getting awesome comments. I mean, Chuck said, query record with the starry eyes. And then, of course, we have Charles Stockman said, are you going to release these slides? Bill, I think we are, right? We got guys in the background who do that kind of stuff, but they'd be able to answer it. But I think we usually make something available. Andy said, thanks, great demo. Steph Nestor said, this is cool, with the fire emoji.
Nice, thank you, appreciate that. Always appreciate the comments. No, that's great, that's great. Yeah, and as you mentioned, this is obviously tried to pick a use case that's relatable, and Hacktoberfest issue triaging, but the principles apply. Take data from one web service, you need to merge it with another web service. Take data from a web service, merge with a relational database. All the power of the NiFi processing system is available to do these kind of complex enrichments.
Yeah, I mean, I'm a user of NiFi. I'm a pretty avid user of NiFi, and I actually learned a few things today, which is
nice.
Which is good.
All right.
I think maybe we need to, I need to up my game a little bit and start maybe playing around with some of the fork and join enrichment processors. I think there's definitely some demos to be had there. Yeah, if you guys have any other questions out in the field, I mean, please let us know. Obviously YouTube, I think LinkedIn also has a method. Unfortunately, I don't think Twitter allows for questions to occur, but so we are on multiple platforms. So
one other thing, just
go ahead.
One other thought, again, I terminated the demo at the persistence, but there's really a lot more you could even do from there. So, in the course of this, thought about, well, GitHub's API is not just read only. We could actually send that data back you'd have to have the credentials to do it, but update the issues based on, or update the pull request based on that issue triage, again, leveraging NiFi's capabilities. So lots of extension points where persistence is really just half the battle in that case. There's a lot more you could do in response to these things on the fly as part of a standard flow.
Yeah, I think that would be awesome to automate. Like, so you're not having to go to two platforms. You're not having to go to GitHub and update the GitHub pull request, and then having to go to Jira and update the Jira, your dashboards, your Kanbans, whatever they have. Right. Sure. You can just do it in one platform and then let this process run, and it'll actually automate the updates in the other platform. But it looks like we're getting some questions in here.
Okay, great.
We have some comments. Andy was talking that leveraging the concept of ETL, I guess it's a tagline for NiFi, and NiFi is based on Niagara files. So that's where the naming comes from. Software developed by the NSA. So for those that didn't know that, it was developed by the NSA. I think it was open source in 2012. Transfer program in 2014. I was off by 2 years. So, but Ayush, if I say it wrong, I do apologize. Amatal says it's an application that writes data into a relational data store like Oracle, but needs some portion of data to be allowed for text-based search. I think it means, is there an application that writes data, not if there. So is there an application that writes data into a relational data store like Oracle, but needs some portion of data to be allowed for text-based search? So
I mean, I can just take a stab at that. You know, might come to mind, say, if you have data you want to send to two different repositories, maybe you have Elasticsearch, or I know MongoDB's done some work recently with extending their full text search capabilities, or, you know, you have some other engine. You know, NiFi could easily filter, fork, and send the relevant data to multiple destinations. So that's certainly a common use case, I think, where you have different, you might have a short-term repository, or you might have a long-term storage service. You know, maybe you want a long-term persistence in something like S3 or Glacier, and you want to, you know, a short-term query in some holding table or relational database. So yeah, all those, you know, again, NiFi has processors for most of the common, both relational and non-relational repositories out there. So that's definitely achievable, if that answers the question.
It does, and actually, that it was thinking, like, can you replicate portion of the flow to something like Elasticsearch, which was definitely answered. And then it's yeah, but is it a good use case for NiFi? Yes, it is. Definitely. So I'll answer that. I work with customers. I mean, David does too, but I see customers every day, and I was a customer, so we have definitely used NiFi to push data to Elasticsearch. You know, part of the things that we needed for queryable search. We've even done it for, you know, NiFi can do some. We've done some OCR stuff. I mean, like, there's a lot of cool stuff that you could do with it to be able to push the data all over the place. And that's the beauty of, you know, what we call universal data distribution. So I know this was primarily just looking at NiFi, but that coined term is because you can distribute the data to multiple sources. You can distribute all of the data set to multiple sources, multiple places, whether it be on premise in the public cloud. You can distribute portions of the data. And so you can have full records go on premise, portions of the data go to public cloud, portions of the data go to a different service. I mean, I've written to 4 different things at once, and that's the beauty of NiFi, because it replicates that flow file across all of them. So
just add another processor.
Yeah, yeah. So Harold asks, before Hortonworks was acquired by Cloudera, they offered HTTP and HDF. Is this product basically HDF? So I can take that, because I used HDF of tools. It wasn't just NiFi alone. They packaged NiFi Kafka. At one point there was something called SAM, which was based on Apache Storm. But this NiFi is, so CDF for Cloudera data flow is very similar, but the form factors are much different. So back then, Hortonworks really only produced something that was on premise. With HDF, that you could run it into the public cloud, but it was an IaaS deployment. What David showed you today is a PaaS deployment on Kubernetes, so drastically different. And then when you look at the stateless stuff and the functional stuff, that didn't exist back then. So, you know, I'd say we've come a long way. David, anything to add, I would say?
Yeah, no, that's a great summary. You know, the merger was before my time with Cloudera, but certainly tracking NiFi over many years, it's great to see the options available. And yeah, as you mentioned, you know, doing development on Dataflow, working with the Kubernetes-based deployments, it's a popular open source option, and you know, it's something we're investing heavily on the Cloudera side. So, you know, whether that's the best fit, or like you said, the stateless functional use of NiFi, you know, there's different use cases for each, and that's part of the power of the platform and the different form factors, is we can help design and deploy what makes sense given the use case.
Yeah, yeah, and it keeps getting better. I mean, God, I remember when I was in the ODOT releases, and
It's been a long time. Yeah,
it's been great. I mean, to see this product grow so fast, I'd say, I mean, it's amazing. So Chris is asking, does this Calcite SQL integration mean Groovy is retired?
Nope, Groovy is still supported. There's execute Groovy script. There's several scripted processors that support Groovy as one of the language options. And of course, you could write your custom code in Groovy and even compile it into an R as an option. But no, specifically, and the reason I highlighted Apache Calyx and its integration in query record is to support that SQL language, or the SQL approach to dealing with records. So you're dealing with record-oriented data. SQL is a nice, again, it's been around for a long time, and it's fits well for that kind of structure. If you need to do more complex or non-structured or partially structured data manipulation, you can still fall back to direct coding in Groovy, and that's still a supported option in Apache NiFi, and I'm sure it will be. So it really depends on the use case, but for structured data, Calyx built-in leverage for query record and others is very useful.
Yeah, and if you think about data democratization, I mean, anyone in the analytics world, SQL is table stakes, right? I mean, you can't do analysis at all in data. You can't be a data engineer. You need to know SQL, but you don't necessarily have to know Groovy. I mean, I'm terrible at Java. I could do it. I mean, just not good. I'm a Python guy by choice, right? And for years and experience, but obviously you could use Python and NiFi too, but Groovy's probably better. I mean, it's got a little bit better of the management of resources. Okay, what else? So Otto asked, I might have missed it, but what processor were we using to put the result data into MySQL?
Good question. Yeah, I kind of glossed over it, but it was put database record. So there are several options available. Put database record is nice because it allows you to configure a record reader, and then you can select even the SQL dialect. So in this case, I'm with the flow running at effectively a scheduled time. The put database record allows you to do an upsert with MySQL. So basically insert if there's no data, or do an update based on the ID field if it already exists. So that allows incrementing, and so depending on the strategy, there's different processors. But in this case, put database record fit nicely along with the rest of the record-oriented processing.
So we have two from Chris, but they're kind of related, so I'm going to group them together.
Okay.
I think they're actually very related. So with the slightly improved lowercase t in the ETL, sorry, that's something I've coined.
Yeah, thanks a lot, John. Fair enough, fair enough.
How does this shift the design decision point between using NiFi to transform versus, say, Spark or Flink? And then the follow-up question is, looking for a rule of thumb guidance on when to use NiFi and when to use Spark or Flink.
Good question. I'm glad to get you to weigh in on as well, John. I think maybe starting on the second question first, and that was kind of the general scope of what we started at the beginning. Where does NiFi fit in the landscape? So if you're wanting to do windowed aggregation and things like computing information, computing results across a stream, NiFi does not have that long-term stream perspective, or similar to Spark. It's not going to have a long-term, pull all the data. You don't want to pull all the data from the repository, run it through NiFi just to, say, run query record against it or something like that. So I think it depends on what you're trying to do, what kind of information you're trying to derive. So again, also another, I think on the data transformation side is where NiFi really shines. Again, we were able, with fork and join, pull together arbitrary REST APIs that are completely different. The structure is different, and the closest similar thing is they were both JSON. But other than that, you really have to manually stitch together things. So that's where, without having to write any code, without writing even any Groovy or Python, just using SQL and query record, you're able to join complex data sets. So that's, I think, if you're looking to do disparate data that lives in two different places, and you then want to prepare it for a more windowed aggregation or something like that, that would kind of be one trade-off point. But you have any other thoughts on that, John?
No, I think you're right. I mean, so you're obviously right, but I'd say to add to it just a little bit, there's more parity, right? So it's getting closer to some of the things, but it really becomes a matter of what is your SLA. So you have to look at the use case dependencies. What's your SLA? What type of operations am I doing? The windowing is very important. So aggregates over windows, when you look at the way that Flink can do, say, a hop, or being able to do sliding windows, the way that it does joins, there's actually, I mean, the Flink product, what we call, CSP or CSA, depending on who you ask and what month it is. But Flink and SQL Stream Builder together, actually, we have a built-in Debezium CDC connector. So like you could do change data capture direct, right? So NiFi is not really going at the log level. So for a use case like that, unless you're using the MySQL one, there's one MySQL change data capture connector. Everything's a JDBC pull out of a database. So you're coming into the front end of the system rather than doing it the write ahead logs or the redo logs in the back end of the system. So there's a little bit of a difference there. The speed of the analytics is a little bit different. I think you can also do inference models in real-time streams. NiFi does have some capability to call APIs to do that. And, we've kind of showed that before. But I think what we'd have to do is say it's use case specific. We'd have to take a look. Generally, if you're trying to move the data from one point to another and enrich the data set, which could include joining some of the records on a stream, I think NiFi is a great fit. When you want to do real-time analytics on the data set, that's where you want to look at, say, Flink. I would say Flink first, then Spark. I'd say Spark, in my opinion, Flink is a better streaming analytics engine, and Spark is better at doing, machine learning and artificial intelligence and batch modes, right? It can process large sets of data, but memory dependencies, right? Flink handles the memory for you, whereas you need to know how much memory in every executor that you're using, driver memory in Spark. So there's a lot of operational tweaking that has to occur, but I think that's kind of my take on it. So now we have from Paul, would you see NiFi taking over Kafka in the longer run?
I don't think so. Again, just going to the current 2022 conference, was glad to present on NiFi particularly. There's other competitors to Kafka out there that have their they support the Kafka API, recognizing it's the standard in a lot of ways. But no, the use cases are different enough that I don't see one taking over the other by any means. But there are definitely a lot of integration points, and that's something I think to keep in mind.
Yeah. So I mean, if you think about it, Kafka was originally meant to be a pub sub, right? That's what it was. It was, you publish and subscribe so you can have faster or slower producers or consumers of the data sets, and the data is meant to be stored there temporarily. It's not meant to be a database to store it in long term. It's grown based upon, the way that certain companies have pitched it. The Kafka connectors have helped make it become a streaming engine. So like NiFi was built as a streaming tool, only as a streaming tool, and that's why it's very good at what it does. It's never meant to temporarily store data so that you can consume it,
multiple times.
It's
same
it's
kind
not
of
really
pub sub model.
It's not dealing with offsets. It's not dealing with, that there's obviously checkpointing and things that occur for it to write to disk and pull it up, and the flow file repository, content repository, data provenance repository, all work that out. But then, I'd say that they'll always work in conjunction. I don't think they'll ever have one versus the other. Although some people think that, you could just do one versus the other. I think you need both.
Yep. I would agree. I think that's a good summary.
So Harold asks, do you see Apache Beam being used with NiFi for ETL automation, or does NiFi have its own automation ability?
That's something where I'm looked at Apache Beam very briefly, but I don't have enough background to provide a good answer on that.
So the automation NiFi has on its own. It's got a rich API. And so we've built automation frameworks where I came from. And then this guy, Dan Chappelson, big props to Dan, actually built the NiFi API. So if you're a Python guy like powerful. Me, it's pretty awesome. But yeah, so there's definitely ways where you could build it. There's a guy who works for us, Nagaraj Jayakumar, we were pulling data out of SAP, and we were building like this whole way to get the data into Hadoop. And we didn't want to wait for the business new view in HANA. And so what we ended up doing is every night we ran a job, and it would go in and it would pull the metadata from SAP for that view that the view was just created. It would then build the entire NiFi flow, build the Hive table in the back end, and then everything would flow. And it was great. You know, the first time we deployed it, we had a guy from the business come in and said, "Hey, we put this into production on Friday. How many weeks before you guys can get this into Hadoop?" And I said, I went in Saturday morning at like 12:15 a.m. And he was like, "What?" And I go, "There you go." I'm like, "It's an automated framework now." Yeah, so you do a lot of cool stuff with NiFi, a lot of automation.
Yeah, there's a rich documented REST API. So yeah, you know, the building, the maintenance of, the status checking, lots of extension points.
Oh yeah, oh yeah. So we have just a comment. Cloudera SSB is awesome for streaming analytics with windowing and SQL, and join desperate data sources from Gustavo.
I think there was a recent meetup on that topic.
Yeah,
actually.
yeah.
So check out the archives.
Yeah, you definitely got to check it out. It's you know, NiFi is what got me here, and SSB is continuing to pique my interest. So I'll say that much. So Chris asks, is there any guidance on process in developing and testing transforms, so Groovy or Python scripts, prior to putting them into NiFi, or is there a NiFi specific API objects that don't work outside of NiFi? So I think it sounds like he's asking about testing custom scripting. So whether it be through scripted transforms, execute script, execute stream command, is there a good testing framework for that? And as before putting them in, and then is there anything that any API objects that don't work outside of NiFi? So I'll let you take that one.
Yeah, that's a challenging one. So, you know, there is the NiFi mock framework for Java for testing processors, but obviously if you're writing in other languages, that doesn't really help. You know, one of I think a common pitfall, just Python particularly, so the scripting processors support Python-ish through Jython, which is a Java implementation of Python. So that occasionally trips folks up who are used to looking for C Python modules that aren't available. So some processor or some of the scripted components do allow you to extend the class path. So one of the key tenets of NiFi is class loader isolation, so that one component does not have to share the same exact version of a library with another component. And that's done on purpose to allow those components to iterate and advance independently without one breaking the other. So for that reason, scripted components are going to be limited in terms of what libraries, at least speaking on the Java side, are available. I'm not aware of a great framework for testing the scripted components. That sounds like a great opportunity for improvement. I know there are efforts underway to make Python a first-class citizen for NiFi component development, so definitely stay tuned for that. And that may also highlight some opportunities to improve the testing cycle. But I definitely appreciate that's a good question. It's a challenging one.
I'm excited about the Python thing. Obviously, I follow the community pretty close, so I'm very, 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 very excited.
Nice.
So Chris, I guess this was a follow-up. Let me see. I have to comment out all the NiFi specific stuff and sort of stub it out every iteration. Is there a way to test the code outside of NiFi and then deploy it, or does everyone build scripts in NiFi? Yeah, there's no real testing framework. I know it's been discussed in the open source community a lot, actually. I think Matt Burgess is kind of, you know, commented on some of it, of how it could be useful. I think in the dev channel, I was reading something recently. Unfortunately, I don't think there's anything yet.
Yeah, nothing I'm aware of, but that's a great question. You know, I'd fire an email to the developers mailing list, or maybe even the user mailing list, see if anyone else out there in the community is worked up something, or it could be an opportunity to, hey, let's get some momentum around this. So great question.
Yeah, Maybe a pull request is in order.
Yeah, that'd be great. That'd be great.
You're good. All right, Harold asks, how about durability? Meaning, if a transform is in process during a NiFi failure, is it logged and restarted on NiFi recovery?
All right, good question. So, guaranteed delivery is a key tenet of NiFi. You mentioned the flow file content and provenance repositories. So, all NiFi processors run with the concept of a session. Similar, you can think database session and transactions there. There's nuances, but at a very high level, when a processor pulls data from the framework pulls data, feeds it to the processor. If the processor throws an exception or fails processing somewhere along the way, the framework doesn't lose that data. It keeps that previous instantiation of the content available, so that say NiFi died right at that point, comes back up, it's able to pick up and send that flow file back to that processor and pick up where it left off. So there are, again, subtle nuances in terms of file syncing that are generally not applicable, but if you pulled the plug, if you're right in the midst of writing that file descriptor, you might have OS questions, though there's even some knobs to tweak in the NiFi properties to really guarantee or really protect against failure. But at a framework level, there are strong guarantees in terms of data durability and processing in the case of error conditions.
Harold also asks, does NiFi support exactly once transformations, or is it more like default? So you just answered that question, so I don't think we really have to go into that again. Chris then asks, is there any guidance on how to include Python dependencies in the script processor?
Good question. I've seen, actually, we've worked through some of these issues on the Cloudera side, and I think this is a good community question. It's probably worth a post on, but I think one best practice in terms of setup, it's a little bit custom to the script itself, but if you have the Python script itself, look for and execute pip to install the module as a first part of the process. That sort of guarantees that it's there, and then proceeds to go from there. So it's not really a first-class citizen, again, along the lines of the testing framework. So admittedly, that there's room to improve there. And like I said, with the development that's coming, I think that's something will also be part of the discussion. But currently, it's basically on the scripted component itself to check whether the dependency is there, and optionally use pip or something to install it.
So Andy makes a comment. Well, it's really a question. Are you excited, John? Yes, I think I said it like 50 times, using hyperbole, of course, but yes, so I'm obviously excited. I've been using it for a while, and of course, having to sometimes build things in Groovy, which is a little bit more performant than the Python version.
Yeah, there are trade-offs.
First tenant, yeah, I definitely want. I definitely want that to happen. So Harold then asks, does NiFi support flow versioning? Can the transform definitions be exported to store versions like Git?
Yeah, so depending on how you configured it, say if the script definition is in the property itself, depending on the processor, I have to take a look, but I think the script body is one of the processors, so you could version that along with the flow itself. So and NiFi registry is the standard tool for which can be backed by Git to version flows. You can also come up with other approaches using the NiFi CLI or REST API that allows you to pull the flow definition as it stands from that process group, and then keep track of it. But basically, NiFi registry is the standard way, and it's also worth noting that NiFi 118, just released a couple weeks ago, made the registry client an extension point. And what that means is it opens the opportunity. There's nothing on the roadmap right now, but it opens the opportunity to integrate other registry providers. So think something, maybe a simplified version that writes Enrich directly from Git. There's some issues there, but there's possibilities as well. So, but flow versioning is definitely a common concept.
Can you migrate a flow definition, export or transfer to another NiFi environment? What would allow for testing a flow before production? So this is really the flow development lifecycle. So.
Yeah, no, that's, again, NiFi registry handles that very well. So I know it's a common deployment pattern is you have multiple environments. You want to test the flow on a development or a staging environment before you promote to production. And so that versioning you can, write with, once you've configured registry, you can then version the flow right in NiFi. So you can make changes, then say commit those changes. You can see those versions, and then on the other environment, say the staging or production, you can select that version when you're ready to deploy it. So that's a first class part of the framework, and definitely a common way of deploying and managing flows.
Yeah, I think that's, we see it all the time where we have the registry across the environments, and then you essentially are able to use the versioning in that flow, and then you're able to either use Jenkins or something to go ahead and do your promotion cycle. Even when, David was showing you the what we call CDF public cloud, right? Cloudera Data Flow Public Cloud. He uploaded it manually, but there's actually a rich CLI. And I've built, and so has David, where you automate, you go into your registry on premise, you pull that down, right? Because that's your development environment. And then I want to put it into the Kubernetes. So I use the CLI, basically upload it into the catalog. I can actually version it through the commands and then go ahead and deploy the flow right away. So like there's a lot that you can do with being able to do versioning and then promoting it between like a dev to a prod environment.
Definitely.
So let me see. So Chris, still on the Python, he's asking if different teams use different Python versions, to what NiFi use cases along with dependencies, like is virtual environment possible or containerized execution? Actually.
yeah, I definitely, again, great question, something that's still being worked. Again, I think some patterns I've seen, again, with Python not yet being a first-class citizen, you can use execute stream that will run a command of your choice, and then you can encapsulate the virtual env from that point, which could then support different versions of Python with different modules, that kind of thing. So again, I really appreciate these questions, and I'm actually, Mark Payne is leading the effort, so I'm sure there'll be a lot of buzz when that is ready. So no pressure to Mark there.
Yeah, I've done. I think
these are definitely kind of the things to consider.
Yeah, like execute process. I think it is one of them.
Yeah, that's another option.
Yeah,
sure.
Like is another option where you actually can point out the specific path to where the Python binaries are, and then you utilize that. So you essentially are doing something very similar to like what a virtual environment would be.
Yeah, so you certainly got to plan your deployment and manage your virtual envs somewhat outside of NiFi. But once you have that structure in place, you can be selective in what you're calling.
Yeah, just point to the path and then call the right like Python 3 or Python 2 commands if required. If you're still using Python 2. Yes. Some people still are, even though it's been deprecated for a while. So Harold asks, does NiFi have security integrations such as secret vault connections, SAML, OAuth, etc.? This is the guy to answer security questions. Thank God.
You've come to the right place. Yeah.
I'm quiet. Go, David.
Thanks. Now, security has been a key feature, key element, key design consideration from the very early days, and it's something I focus on regularly. So I spent a lot of time on speaking on the authentication side. We recently, I think at NiFi 117, refactored SAML support. So that's Spring Security SAMLs. That was introduced in NiFi 113, initial integration, and now that Spring Security has made some efforts on maintaining that. We've kept up with that and are using the current versions available. OIDC is a very popular service. There's some open issues on that in terms of particular integration details, but yes, you can configure your own private key cloak instance. You can integrate with Okta or Google. Pick your identity provider. That's a very common option. As far as secret stores, there's 2 levels of property integration. Several, I think it was NiFi 1.15 incorporated support for all the major cloud providers plus HashiCorp Vault in terms of your application properties. So things like system key store and trust store passwords, the sensor properties key, those can be provided from external stores. And NiFi 1.18 was a big release for property parameter providers. So this is at the flow definition level. So it included AWS, HashiCorp Vault, and GCP. There's a pull request up now for supporting Azure Key Vault. So making these first-class citizens as well. So that's now out in 1.18 for most of the providers, and it's an extension point. So there's more work to be done there, and I'm sure there'll be tweaks along the way, but this allows you to parameterize your flows, as I touched on, things like database, username, and password that could easily have been pulled from a secret store and then integrated right in your flow.
Awesome. Yeah, see, I told you had the right guy. I wouldn't have been able to answer that.
Yeah, check out my, I'll plug my blog, exceptionfactory.com. I often write about security related things, particular to NiFi. So if you're interested in the gory details, check it out.
Yeah. Yeah, I usually go to David if I have security questions with NiFi, so he's usually my go-to. So Harold asks one more question. He says, it looks like NiFi is in a send and forget service. Does it also support a request reply like blocking process model?
That's a good question. Depends on the protocol and what you want to do. So one example comes to mind is on the receiving side. So handle HTTP request and response. You could do something where you receive a request and you process it asynchronously and just return a response, say accepted. Basically, I've received it and I will now go off and process. Or you can have the response wait until the processing is done. And there's a lot of important design considerations in that. For sending, it's a little bit different, depends on the protocol. Again, something like syslog, again, it's been around forever, but it's still used commonly. It's kind of a fire and forget. So there's no real delivery guarantee other than the TCP protocol itself. Whereas other kinds of processor, the published Kafka processors, you can configure what kind of delivery guarantees you want. So it's somewhat of a use case specific question, but NiFi definitely supports different strategies depending on what you need and what the protocol supports.
Yeah, if you think about it, tons of building blocks, so you can build a flow out that kind of has that kind of send and receive model, or process blocking model. Harold asked about your website again. So it's a series of blogs. It's not just one, but it's Exception Factory, exceptionfactory.com, and you can follow David on Twitter, Factory. And I believe that he is also known as Exception Factory in the NiFi Apache community.
Yep, Exception Factory at apache.org. Also on GitHub, yep.
All right, so I think that's all the questions that we have. So first, I want to thank everyone for asking questions. There was a lot of questions.
Great questions.
Like tons of interaction, really, really good questions. David, thanks for sticking around, and thanks for filling in for Mark. I know it's not exactly probably what you wanted to do on a Wednesday night, but here we are.
That's great.
And now we can go get a beer soon. But yeah, thank you everyone. Really do appreciate it. But remember, we did promise that if you were interactive with us, we're going to go ahead and draw a name. So I believe we're gonna cut over right now. And so what I did is, if you posted anything in the Slack chat, unless you're a bot, we did separate out the bots. We actually have all the names associated with it right here. So we've been talking to them. So we're gonna go ahead and we're going to click to spin and see who's the winner. And it looks like it's Pat. So Pat Bohr, if you're still on the call with us, please give us your email address. We'd really appreciate it. Pat, if you can, you can either hit us up or Bill, I'm sure you're working your magic in the background. So we have people, we have Bill and Emma in the background who you don't see. These events take a lot of work actually, and so they've been doing a lot of planning, and they're the ones that are cutting screens and listening to, hey, maybe you should just make the screen a whole screen sort of deal. So really appreciate the work from Emma and Bill in the background. So he has so Bill, okay, so Pat, you have to email us, Bill, if you want to do your email, my email. What do we do as the email? I forget. I'm terrible with this. So if you want to email us at Cloudera, let me, sure. There you go. Social media at Cloudera.com. So social media at Cloudera.com. All right. So if you can give us an email, social media at Cloudera.com, and let us know, we'll send out, give us your address, of course, name and address, and we'll send this out to you. So that's pretty much it. So want to thank everyone. When's the next meetup? Let me see. I think I should be more prepared. So we actually have, don't know if we have a meetup. Oh, I got to draw the second name. That's right. That's right. So go ahead and remove Pat. So we got one more. Forgot there were 2 prizes. I don't pay attention. There you go. Ayush, if I'm saying it right. So want to make sure that you email socialmedia at Cloudera.com. That's socialmedia at Cloudera.com. So make sure both of you guys email us and let us know. We do have resources. So there's, of course, some papers. And then essentially, we'll be doing meetups relatively soon. So please make sure that you're following the meetups page. We actually are going to start probably trying to do meetups in person again. So for those that are coming in from the different meetup groups, please pay attention. I know we just did a meetup in person on Unicorn out in California. And so as the guy who runs the Philly area, look for Philly, New York, that kind of area for me, Philly, New York, and Princeton. So we'll be running something relatively soon, but that's pretty much it. We want to say thank you and good night.